welcome Francesc on stage for our first talk. And while he's walking here, we need to give him a loud round of applause. Because he has been cycling from San Francisco to LA, wearing a red tutu. Right? He's done this twice. He works for Google. He's a Google advocate. And he's the developer advocate. Oh, my God, not Google advocate. He's a developer advocate for Google, for Golang. And he's been through, in the last 1 year, he's been to 12 different countries. And he's lost count of it. And because I can't help it, I have to take a dig at you, Francesc. You're a big Trump supporter. Sorry.
Yeah.
And, if you're all set, let's welcome Francesc and let's the conference going, guys.
As he said, I'm a developer advocate. No, I do not support that thing called Trump. Anyway, so I don't know how many of you were yesterday at the workshops. If you were there, this might sound familiar. Is the Wi-Fi working? So we're going to try that first before I start my talk. And it is slightly related to the rest of the talk, don't worry. So if you've ever written some Go code, you might know that this is a good way to check if the Wi-Fi is up or down or not. Google is always up. That's pretty much true. So we could ping Google to see if it works, check that we get status OK, and that's it, right? And then we can check if ping Google returns true or false, if it returns a nil error or not, and then with that we know if the Wi-Fi is working. Let's try it. So I'm gonna run this, and yay, the Wi-Fi is working. Awesome. So next is, what happens if the Wi-Fi is not working? How long is that function going to take? Do you want to cancel it? After how long? If you cancel that and there's things behind it, should also those be canceled? How do you manage all of that? And that's the context package. We're going to be talking about how you manage things that need to be canceled over the network, and in some cases, in quite a cascade way, where when I cancel something, the rest should be canceled. Writing that by yourself is hard. So the Go package, the Go standard library provides a package that does exactly that in a very nice way. Today I'm going to be talking about exactly that. It's one of my favorite packages, so I'm going to be talking about the API. I'm going to be talking about why the API is the way it is, and then about some little pearls in the implementation, which I think are a really smart way of writing Go code. And I hope that from there you will learn something. Before we start talking about that, 2 years ago, we were in Bangalore, and that was the first GopherCon, and it was a GopherCon India. It was an awesome conference, and also we discovered Pan. That thing's pretty strong, by the way. Dave Chen is not here, but if he was here, he would agree that the conference is amazing. So I want a round of applause for the organizers that are doing a great job. That is not my best picture. OK, so let's talk about the context package. A little bit of history of the context package. We all know that it was added to the Go standard library with Go 1.7. But it's been there for way longer. Before being part of the standard library, it was actually a package in the X subrepo. So it was golang.org/x/net/context. And lots of people have asked what X stands for. And I think it was Brad Fitzpatrick that said the X stands for cool. It's also the things that we can break quite easily without anyone complaining, because it's not part of the standard library. But even before that, it was actually created at Google for our own problems. We need to handle cancellation of tasks across the network. So we wrote that code, and that was in 2013. So the code is already 4 years old, even though it looks like it's only 6 months old. The whole thing is 492 lines of code, if you do not count tests, you should write tests. There's actually more lines of code of tests than actual code, which is good. And it's only 369 without comments, according to grep-v. So in only around 400 lines of code, it exposes only 2 types, and one of them is just for documentation. So how interesting could a package like that be? And I'd argue that very, very interesting. It's actually one of my favorite packages, and I hope that by the end of the talk, if it's not one of your favorite packages, maybe you do not have favorite packages because you're not that geek, that's fine. But I hope that you at least will appreciate a little bit more how it's being built and how it works. So the context package has one main type. There's the one that we all use, which is the context interface. And the context interface has 4 methods: done, error, deadline, and value. And that's it. That's everything it does. The done method, what it does is that channel will be closed whenever the context has finished, either because it's been canceled or because the timeout ran out. So we ran out of time. Once that channel is closed, calling error will return an error that will not be nil. It could be either cancel or deadline exceeded. Those are the 2 only values that it can return. So, just knowing that, how could we cancel the ping from before? So we can do a ping with context, and what we're going to do is we're going to receive a context, and that ping Google, we're going to call it in a different Go routine, just so we can send the error through a channel. That's everything I'm doing. It's basically calling the same function, but just sending the error to a channel rather than waiting for that function to finish. Now I have the freedom to use select. So I can say, if by any chance I receive something from that channel, it means that we're done. So I can return that error, either nil or something else. Otherwise, what I'm going to check is that if the context is done because the timeout arrived or because the context was canceled, then we'll return the error. That could be either deadline exceeded or canceled. And now that I notice here, there's actually a little issue here. We will leak a Go routine, so that should be make channel error 1. Otherwise, it will leak a Go routine. If you don't know why, talk to me later. Okay, so how do you call that function? You call ping with context, and you pass a context. How do you create that context? Context is an interface, so you cannot just create an interface value. There's going to be nil. So how do you create it? There's actually a bunch of different ways. We're going to start with background and to-do. So background and to-do do exactly the same thing. They return a context that is never canceled. Therefore, done is never closed. Therefore, error will always return nil. And there's no values, there's no deadline, there's nothing. Just that. And we have 2. We have background and to-do. We can use background and just call it. And now it works. This is exactly the same code as without using a context, because there's no cancellation and there's no timeout. So it's just a fancier way of writing exactly the same thing as before. We can also pass to-do. And what is the difference between passing background or to-do? They do exactly the same thing, so technically it's exactly the same. But actually, they're not exactly the same thing. That's why they have different names. So background in a func main makes total sense, because you're still not reacting to anything. It's not because you got a request and you're reacting to that one, so you're passing it along. You're beginning the whole context. So that is background. While to-do is, listen, I know I need to pass a context, but I still have no idea which one. So let me pass to-do, so this compiles, this kind of works, and then we'll keep on working on it later. So that's why we have to-do and background. Normally, you should be using background, unless you're refactoring, and then to-do makes sense. Oh, have no water. Okay, so we have with cancel. And with cancel, you're going to see that with cancel receives a parent context. And this is actually the case for the rest of context. you're going to see that actually a context is not just a context, it's a tree of contexts. We'll see an image for that in a minute. When you call with cancel, you need to pass a context, in this case with passing background, and then you get that function cancel that you can call whenever you want to cancel something. In this case, I'm canceling the context after 1 second. I'm calling time.afterFunc, which according to the specification, the documentation of the standard library, what it does, it just calls that given function after the given duration. And also returns a timer that I'm not using. It is optional to use, so I'm not using it. So what this is doing is, if for any reason the ping to Google takes more than 1 second, we will just stop. So now we added the fact that we know that our ping Google operation will not take more than 1 second. So let's try it. Ooh, that's big. Okay, with context. So I can do, this is the code we had before. So go run with context.go. The Wi-Fi is still working, good job. We can do context equals context with timeout. The context, no, sorry, no, I'm going too fast. With cancel, context, and that will return a cancel, and time after func, time.second, cancel. This is wrong because we need this. Okay. So if the Wi-Fi is fast enough, this still works. We're totally fine. If we start asking for things that will not happen, like it needs to take less than 1 millisecond, we will see that millisecond is spelled with 2 L's. And the context was canceled. The context was canceled before we got to send a message. And that is normal because our Wi-Fi is not that fast. Actually, I don't think that any Wi-Fi will take less than 1 millisecond to ping Google. Cool, so we have the context, background, and to-do, which is the basis of the things. And then we can add cancellation. When you add cancellation, the cool thing is that you can do it after some time, but you can do it for any other reason, like you react to Control-C or something like that. That's a pretty normal case to do. What about deadline and timeout? Well, they're exactly that. They're exactly the same thing. They're exactly the code I wrote here with cancel, and then after some time, you call cancel. But the only difference is that this will set the error to be deadline exceeded rather than cancel. So if we do the same thing, so we're going to do with timeout, time.second. Important, we need to remember to call cancel. Even when you're not canceling the thing, you need to call cancel because that will release some of the resources that with deadline creates. Specifically a timer, it will stop it. If you do not do it, it's not like a big drama, but it's better to do it all the time. And actually, if you don't do it, I think that GoVet will complain. Okay, so let's try again. This should work. But if we go down to a millisecond, this will not work anymore. But now, rather than cancel, it says context deadline exceeded, which is slightly better. Whoop. And finally, we have with value. And with value, the way you use it is you pass a key and a value, and it just stores it there. And why do you want to do this? There's actually enough content for a whole talk, so I'm not going to get too much into detail. But basically, what you want to store in a context are the things that are related to the request. So request scope values, like IP of the requester or basically headers from the request, stuff like that. You can store it there. That's OK. Actually, you could store the whole request if you wanted. But you don't want to store things that are obviously important. Those are parameters to functions. Or things that are not related to a request, like a database connection. Those are not the things that you should be storing here. But anyway, you store something, and then if ping with context was passing it around to some other function that knew about user ID key, it would be able to retrieve it. And we'll see later why this works, even though many keys could be the integer 0. How does this actually work? OK, so We've seen that you can create background. From there, you can create a with cancel. So what you're doing is literally creating a tree of context. And then you can add a value and another value. And the good thing is that since this is actually a tree, you can create other branches without having too many copies. So you can add a deadline and send it to a different request, and then add a value, send it to a different request. So this is pretty nice, right? Like you start creating a tree, which kind of matches to what your request is doing over the network. You're sending it to a bunch of different servers, so this kind of what it will look like. Okay. So we've covered only 2 of the methods. So let's go back to the interface. And let's talk about actually still the error. So when we call error, that returns 2 errors. Either cancelled, which we create but with errors the new, or deadline exceeded, which we create with deadline exceeded error. Why? Why would we do this? And this is actually a very cool thing. So what we're doing is we have this concrete type. And this concrete type is not exported, so no one can see it, right? So what's the point of doing this? Well, we're defining it to have an error method, because it is an error. It needs to satisfy the error interface. But also, we're adding timeout and temporary. So why would you add 2 exported methods to an interface, to a type that is not even exported? And the point is that this allows us to check for things without knowing what there is behind. If we receive an error, we know that there's a method, error, that returns an error. But we can easily check, does this type, whatever it is, also have a method temporary? And if so, I'm going to do something special about it. So you can write this kind of code. So now, this means that no matter what type you're calling, if you know that, oh, is this a temporary? If it is, call the temporary method. And if that returns true, then the error was temporary, so we should retry again. If it's not temporary, it means that you just misspelled Google. Like, it is not that Google is down or the Wi-Fi is down, it's that your URL is wrong. In that case, you should stop retrying, because there's no point. And there's a really good talk by my dear friend, Dave Cheney. And the name of the talk is Don't Just Check Errors, Handle Them Gracefully, which is a Go proverb. Go Proverbs, there's a talk by Rob Pike with all of them. And I recommend trying to read all of them. If you don't want to watch the talk, it's fine. There's a web page with just like the Go Proverbs, and try to see how you apply them to your code. But anyway, also the talk is really good, GopherCon 2016, and it talks about how errors are more than just little values. They're actually values that are part of a type that can satisfy interfaces, so you can do really cool things. And you should think about it when you're doing big systems. Okay, third method, the method deadline. This method is pretty simple, and I'm not going to talk much about that. It just returns what is the deadline. So if I say you should stop in 1 minute, well, it will be in 1 minute, and I don't have a clock. But you can imagine in 1 minute, whatever time that is. Why do we use this? Well, imagine that you're writing a function and you receive a context. And you know that starting the process of whatever it is, it's going to take half an hour. And you see that the context will be canceled after 10 minutes. There's no point on starting. So that's why you can use these things. You can check, oh, if there's no way I'm going to finish on time, I'm just going to be done and return an error saying canceled already. That's the thing you could do. And then finally we have value. And value returns one of the values that was added with value. And the cool thing about this method is that the key is an empty interface. It is not a string, it is not an integer, or in 64, it is an empty interface, which means that you can pass any type, any value of any type that has at least no methods, which is any type. You can pass whatever you feel like passing. So, what does this mean? If you go read the code specification, which I recommend, it says that 2 interfaces are comparable. Well, 2 interfaces are mostly always comparable, but they're equal if they have the same dynamic type, meaning that they have exactly the same type, And then also they have the same values. So that is interesting, because then that means that if I have a library on one side that defines my lib key as a new type, which happens to be an integer, but I define as a new type, and it's an unexported type. No one else can see it, just my package. And I use the value 42, because I'm a geek, of my lib key as a key. Then someone else is as original as me and creates a new type, also unexported, and uses the value 42 also, but with a different type as the new key. So what happens if later on I want to retrieve the value 42? There's actually no such thing. You need to say, which one, my lib key or my other lib key? And that will totally work, because my lib key and my other lib key, even though they have the same value, they're actually different types. So as empty interfaces, they're comparable, but different. And that is actually something quite cool, because it allows you to use any key you want in the context without having to care about any kind of complex conflicts across different namespaces. Still on the context interface, and now we've been talking for 20 minutes of one interface with 4 methods, which is not too bad. The fact that it is an interface. Why? Why is this important? There's a couple reasons. One of them is you have no idea how this is implemented. And not only that, but the implementation has changed completely since it was internal at Google until it was open source. It's completely different, nothing to see one with the other. And still, the API is exactly the same. So that is the power of interfaces. You can hide that complexity. But also, and even almost more importantly, is the fact that this is an extension point. You can and you should define your own context. If you want to do a context that does something specific, like imagine that you're sending a HTTP request, and you want to get, I don't know, the body of the request, and store that without decoding it or anything, and you just want to pass it around, and then send it somewhere else. You want that specific context, which is a very weird thing just for you. You can implement it. That is totally fine. The only thing you need to do is satisfy those 4 methods, which is pretty simple, and that's it. You're done. So that is a very powerful thing. Okay, so we've said that context interface is about cancellation. Why isn't there a cancel method? It would make sense. All contexts could be cancelable, right? So, and they have done, because all of them could be canceled at some point. So why don't we have cancel? It is actually basically UX design here. Imagine that I have this function, dual, and I create a new context, and I'm passing that context with a cancel function, and I pass the same context to 8 different Go routines, okay? So basically what I'm saying is I start 10 different Go routines, and I tell them all to go there, and as soon as I get one of the responses, I'm just gonna cancel that original context, and then all of them will stop. Cool. What happens if one of them calls context.cancel? That one will cancel all the Go routines. That is not what I want. If I give you a context, I am the one that manages the cancellation. If you want to cancel a context, you create a new one, and you'll be able to cancel the subtree, but not my subtree. My subtree is mine, and you cannot touch it. And that's why there's no cancel method, even though it would be really easy to implement it, to the point that there's actually a cancel method, but it's not exported. There's actually a cancel method with a lowercase c. Is there any water? Thank you. Okay, so let's talk about the implementation now. We're done with the API. Let's talk about the implementation. So we have a context interface. You could imagine the way to satisfy it is by defining a context type. Context struct that has, if this is an interface, this is the struct, pretty much. Modulo some mutexes and stuff like that. But you could do this. And this is actually what the first version did internally at Google. But this is not what the code looks like now. Now, instead, we have 5 different context types that all satisfy that interface. And why do we do this? There's actually some very good reasons. One is you're actually having a separation of concerns. Every single one of those types is concerned about a specific feature. The cancel context knows about cancellation. It doesn't know anything about values. The deadline context, that is wrong. There's no deadline. It's actually called timer context. Forget about the one in the middle. It's not there. The timer context knows about deadline and timeout, because they're basically the same thing. And then the value context knows about values, and the empty context doesn't know about anything, really. It's super simple. And so that is good. It makes our code easier to follow, easier to understand. The other good reason is this struct is actually quite big if you need to allocate one every single time you create a new context. Especially if what you're creating is an empty context. An empty context should be empty, should not take any extra allocation. But in this case, that empty context could have at least, the deadline plus a map plus an interface plus a channel. There's a decent amount of memory that you're wasting. By doing this, every single allocation is limited to what we actually need. And when you have so many contexts, because we're going to be passing context to basically every single function in the world, that is very important. Okay, so let's go through the context that we have. The first one is the empty context. And the empty context is empty, simple. Doesn't need to know anything. It just knows it's never canceled, never returns an error, never returns a value, and never has a deadline. So easy. We create an empty context, and then we say we're going to get, since we want background and to-do to be different values so we can compare them, right? So we create a pointer to an empty context, right? Because if you had two empty contexts, if you compare two structs, what you're doing is comparing the values of the fields. If there's no fields, all of them are equal. So you're going to do that. So instead, I'm going to call new, so I get a new pointer. So I have two different pointers. And we can compare them, and we can create a string method on it. And now the string method, what it does is, well, if you call string on an empty context, I'm going to check for the pointer. And I'm going to say, if it's background, print background. If it's to-do, print to-do. And now I write print to-do. It says background. Why? And this is weird, right? Like, why would this do this weird thing? Where is the bug? Well, turns out that an empty struct is actually empty. And the size in memory is actually 0. So if you have one address, and then you allocate 0, and you take the next address, happens to be exactly the same address. So you're actually having two different structs. Now, you're actually having two different pointers to exactly the same area in memory. And this is part of the specification of the language. So you cannot do this. What's the fix? Int. Done. And then you add double quotes, because now it's the empty context. And that's it. This is the whole code that you need to know. It's actually very simple. Next, we're going to be talking about the cancel context. And the cancel context starts to be more interesting. Oh, the other way, sorry. Okay, so the cancel context has a context, has a channel, has an error, and has a mutex. The mutex is important because we're going to be modifying the error at the same time that someone could try to access it. So we need to protect it to avoid having any data erase. So you have done, that returns the channel. And it is important that here, done is the channel of structs, of empty structs. We have an empty struct because we do not care about the information we're passing. It is the fact about it is closed. That's it. That's everything we care about. But look at the type. It's just a channel of empty structs. But when we return it with done, it is now a directed channel of empty structs. That little arrow there, what it means is that we're returning that channel as a channel that you can only use to receive from. You cannot send stuff to that channel, and you can definitely not close it. And that is important because otherwise we will be providing a way to cancel context without really meaning it. That's why we have that little arrow there. And then when we return error, we make sure that the lock is logged to make sure that we don't have any data erases. Cool. What about the other methods? We're using context without any name in there. So that's what we call struct embedding. And struct embedding, what it does is it exports all the methods that are in that interface onto our type, except for done and error that we are redeclaring. So value and deadline are exported by that one. So with that code, you're already satisfying the whole interface, which is pretty nice. Now, for the hard part, and this is actually the part that got me excited about this context package, because it was like, this is so hard to do. And then I saw a line of code, and I was like, oh, people are smart. So you have background cancellation, cancellation cascading, not background, cancellation cascading, which means that when I cancel this context, this one should be canceled too. That is the whole point of context. If that didn't work, we would be wasting our time, really. So how do you implement this? And think about it. How would you do this? My first reaction was, I'm going to have a list of context that I need to cancel, so the parent keeps track of all the children. Or maybe I'm going to have, since context doesn't have a cancel method, maybe I'm going to keep cancel funcs. Like every single time I create one, I'm going to keep track of it. I do not know. This seems hard. And then you think about the fact that this is Go. Everything you do with Go routines and channels. So this is a brilliant piece of code, in my opinion. What we do when we create a new cancelable context, we're going to create a new Go routine. And that new Go routine will try to wait until the parent is done or the child is done. If the child is done, we're done. That Go routine can die. If the parent is done, we should cancel the child with the same error as the parent did. That's it. And I find that brilliant. It's a super smart way of using Go. And it really shows the power of concurrency and channels and Go routines for something that, if you think about it, there's no concurrency. There's no parallelism involved with this. It is just concurrency. It is not parallelism like we need to run it many times. And no, this is actually totally sequential. As like you cancel one thing, then you cancel the other. But you're able to express it in a very much more natural way by using concurrency and Go routines. So does that mean you're creating a Go routine for context? That's an awful idea. Not really. Like I demoed yesterday a little thing where you can run 16 million Go routines and it just works. So it's not such an awful idea, but it is true that we could do better. So the standard the package in the standard library does actually do better. It does have that piece of code, but that piece of code is only done for things that we do not know how to cancel. If we know how to cancel them, what we have is we have an interface called canceller. And this is kind of cool because the canceller interface is not exposed. You cannot see it, but it has two methods. The private cancel method, which means that no one else outside of this package will be able to satisfy this interface, and done, as before. So now we can actually write our code and keep a map of cancelers. So we're actually keeping track of all the things we can cancel to avoid creating too many Go routines. But that is more of a performance optimization to have less allocation of Go routines rather than our main problem. Our main problem can be solved super elegantly with just Go routines and channels. Okay, so what about all the other contexts? We said the deadline context and so many others. Just go read them. This package is very short, and I'm not going to explain the whole thing and the whole story about it, but in only 30 minutes, we're able to go through a bunch of different things, and every single line of code has a lesson to be learned. So my advice to you is go read it many times, and as long as there's a line of code that you do not understand why, try to understand why it's there. Try to use git blame. Git blame is not only about culpabilization of people, it's also about archaeology and trying to identify why this was done this way. So I hope that with this, you're going to get excited and try to read this package, and after those, way more. Thank you. And I don't know if we have time for questions.
Yes, we do.
Cool.
We do have time for questions. And just raise your hand. We have a few volunteers going on the mic. All right. I think it requires a little more than just coffee.
Yeah.
There you go.
Thank you.
I was wondering, how does context do cancellation over the network? Does it maintain its own RPC endpoints?
So it's actually, that's a very good question. It actually depends on the way you're doing it. When you do, for instance, HTTP, there's actually a specific context that I'm not talking about, which is the HTTP context that passes around, and that's the one that handles it. I'm actually not sure how it does it concretely. The way I think it's done is for deadlines, it is just a copy of the value. So you just pass in the deadline, and that's handled directly. For cancellation, I'm going to assume that for HTTP is not something you can do, because you need to send one more request, and how do you cancel that extra request? But for things where you're doing, for instance, gRPC, that totally makes sense, because you're actually doing streaming, so you can actually close it and say, hey, we're actually done, so the streaming stops. But yeah, for HTTP, I'm actually not completely sure. I should read that. Should read the code. Yeah.
Nice. Any other questions?
Hello. So, Francesc, I mean, can you show the code of ping Google? I mean, I have a little question there.
So, I saw the guy next to you. I was like, what?
Okay, so see the code.
Yeah.
So in the ping Google method you're shown, right? Method that ping Google. So there you have started a Go routine, which actually make a request to Google, right?
Yeah.
So, but inside that's a separate Go routine. So even though we cancel it, that Go routine will still be running till the actual request is done, right?
In this example, yes, because there's no way of canceling that. Actually, if you wanted to do it correctly, when you create with HTTP GET, you cannot do it. But you can do HTTP new request and say, I want to create a new GET request. And in there, you can actually add a context. But that context, I'm not sure if the cancellation is going to be that useful, or it is more to be able to actually pass all the values and deadlines that you have in that context to the server where you're sending it. As I said, I'm not completely sure that HTTP cancellation works, unless it is like something slightly more complex as gRPC that works over HTTP 2. I do not see how to do it over HTTP 1.
Okay. Thanks.
Thank you.
And we have a question.
If anyone knows how to do it, by the way, I'm curious, sincerely curious about how to do that. There's someone down there raising their hands.
Yep. We just get a mic to you so that we can record the questions properly.
This really feels like a wedding from here.
Hi, Francis.
Hi.
So the question is more of from design perspective.
Can you talk a little bit louder? I cannot hear you, sorry.
Can you hear me now?
Yeah,
okay.
Now yes.
Yeah. So the question is more from design perspective. So suppose we have a package and we need to maintain, context for that package. So in that package itself, we implement that context. And now we have a user of that package, which itself could need, could have a need to create its own context.
Yeah.
So from design perspective, can you give some insight on this?
So if I understand the question is, what happens when you have many different context types and you want to pass them around?
No, not exactly. Should we have different context types or not? Or when should we have?
Only when you actually need it, and you actually need it for two different reasons. One is you want that context to do something that the current library does not do. So you want to add something specific, like what I was saying, like shallow copy of the request so you can send it around without decoding and stuff like that, like some slightly fancier things that this package doesn't do. The other reason that you might be interested in doing it, and I'm actually going to show, no, I'm not going to show any code.
Yeah,
there's, for instance, Go Buffalo. I don't know if you've heard about it. It's an HTTP framework. It's a web framework for Go. And I met creator of this package when we're in Italy, and we're talking about the context package. They do have a context type that does not satisfy the context interface. It did not. Now it does. And the whole point is that that context has way more methods. It does many things that the context package does not provide. So it makes total sense to have a context type that provides extra functionality, so you're using it in your framework, but then it does satisfy the context interface, so you can use it with the rest of the standard library.
Okay, thank you.
Thank you.
We have another question here.
Yeah, hi. It's nice pointer and context. So my question is about how do we go about testing the context? Is there any package available like what we have for HTTP test? Is there something like that?
So there's no extra context test or something like that, like HTTP test. But if you want to test it, there's actually the code that tests it is in there, context_test.go. So I recommend reading it. It is also very interesting. The most interesting part of it is that when you do these kind of things, you want to test many things that are not easily testable. Like you want to test that there's no data races. You want to test that the deadlines actually happen when they're supposed to. So there's a lot of different ways of doing this. It's kind of complex. Read the code. It's complex to explain. It's not complex to read. So that is, I definitely recommend going and seeing it. It's definitely worth it. And you can apply the same idea to other packages where you're depending on time and channels and stuff like that.
All right, last call for questions. All right, thank you so much, Francesc.
Thank you.